Hi class, this video is about the pH scale, and the pH scale is a measure of how acid or how basic a solution is. And if we see the H in pH, that H represents the hydrogen ion, and this hydrogen ion is donated by acids. And the hydrogen ion causes the pH to decrease. And so I'll put an arrow here to represent to decrease. And the pH scale is a relative scale of how many hydrogen ions are present in the solution. And we see that it ranges from pH 0 to 14 down here, where as you go closer to pH 0, that indicates that you have a very large concentration of hydrogen ions in that solution. And remember, acids are substances that donate hydrogen ions in solution. And for example, if we take a look at lemon juice of pH 2, which is classified as an acid, we see that in a solution of pH juice, that solution has many hydrogen ions as seen here. But we notice there's another type of ion in the solution, OH negative. And OH negative, that is the hydroxide ion. That should be an R there for hydroxide. And the hydroxide ion, it comes from bases. And we can define bases two ways. One, bases can donate hydrogen ions in solution, or bases can absorb hydrogen ions. Either way, bases cause the pH to increase. So we're at the word increase here. And what we mean by increase in that the pH goes closer to 14 because you're either adding hydroxide ions or you are removing hydrogen ions. And if we take a look at this solution of bleach, we see that there are many hydroxide ions in that solution of bleach, causing that pH to increase, go, in this case, pH of about 12.5. And we see that when the concentration of hydrogen ions are equal to the concentration of hydroxide ions, the pH is said to be neutral, pH of 7, and that's because they actually combine to form water. Because we have H plus H is 2 with one O with H2O. That's the pH of 7, which is neutral, and pure water has an even number of hydrogen ions as well as hydroxide ions. Now, one more thing I need to mention about the pH scale. The pH scale is basically a log scale. Which means it's based on the number of 10. So every time we go down the scale or even up the scale, it's not a change of 1, but it's actually a change of 10. So for example, as we go from pH 1 to pH 2, that's a difference of 10 times because we move 1 time. And in terms of how many more or less hydrogen ions are present in pH 1 to pH 2, remember, as you go closer to 0, you're increasing the number of hydrogen ions. So if we're going down the scale from pH 1 to pH 2, at pH 2 we have 10 times, so we're at X here, 10 times less hydrogen ions at pH 2 to pH 1. And likewise, if we go to pH 2 to pH 4, for example, we've moved 2 times. Every time we move, that's a change of 10, so that's 10 and 100. So that's a difference of 100. And as we're going down the scale, we are decreasing the concentration of hydrogen ions. So pH 4 has 100 times less hydrogen ions. Now, let's review some concepts about buffers. So what are buffers? Buffers resist changes in pH. And by resisting changes in pH, buffers help to maintain pH, which is very important for homeostasis. And in class, we talked about our blood pH being about 7.4, and it can be at 7.4 because we have buffers in our blood to help maintain that pH. And buffers are a system of a weak acid with its conjugate base. And for example, the buffer system that's in our blood is actually carbonic acid. So it's H2CO3. And we write the name here, carbonic acid. And it's an acid because when it's in solution, it actually donates hydrogen ions. And that's why it's an acid. And once carbonic acid donates a hydrogen ion, the conjugate base is formed. So the conjugate base just comes from the acid once the acid donates a hydrogen ion. So carbonic acid's conjugate base would be bicarbonate, and I'll write it here. So it's HCO3 minus, and the name is bicarbonate. And this is actually a buffer, and let's examine how it works. And before I forget, this reaction is actually reversible, and so we can actually go in the left to right direction or from right to left. Now let's see how buffers work. Let's say, for example, you have too much base in your system, so you may have too many hydroxide ions in your system, and that will cause the pH to increase, go closer to 14. Your blood pH is about 7.4. And the hydroxide ions would cause the base to increase, go closer to 14. In that instance, the carbonic acid would donate hydrogen ions. These hydrogen ions would combine with the hydroxide ions to neutralize it, thereby resisting the pH change and maintaining the pH. And so again, the hydroxide ions will cause the pH to increase, but we will neutralize it with the hydrogen ion, maintaining a pH close to 7.4. Okay, so now let's review what happens if you ingest too much acid. And so let's say, for example, you ingest too much acid and you now have an increase of hydrogen ions in your system. Those hydrogen ions would cause your pH to decrease or lower, go closer to 0. And in that case, the base side of the buffer, bicarbonate, if we see the negative charge on bicarbonate, the bicarbonate would combine with the hydrogen ions, and that's how you remake more carbonic acid. And thereby removing the hydrogen ions, you again neutralize that acid. You resist that pH change, and you thereby help to maintain your blood pH of 7.4. And so that's how buffers work. Depending on whether you take up bases, the carbonic acid side will work for you. If you take in acids, the bicarbonate side will work for you. Either way, we help to resist the pH change. I hope this video on the pH scale and buffers helps you. Thank you for watching.